Alright, what's up guys? In this video we're going to pick up some more calculus. This is going to be another integration practice video. This is going to be example number 10. So let's work on that one. Okay, here, so we're asked to evaluate the integral, the square root of 9 minus x squared with respect to x. So this is just another trig substitution. I've done plenty of videos on trig substitution, and in my opinion, you can never get enough because trig substitution tends to be a hard technique to learn. So I got plenty of videos on them, and this is just going to add to the collection. So since I have plenty of videos on them, I'm not going to go through a thorough explanation of trig substitution in just this video. So check out my other videos for more detailed explanations. All right, so there's typically 3 trig substitutions, so we can rule out the fact that this is a tangent. It's not a tangent substitution, and it's also not a secant substitution because the x squared would appear first. So this is clearly a sine substitution. Remember, trig substitutions don't have to be under square roots, but they're easily identifiable if they are. They don't have to be. So remember, if I see the square root of a squared minus x squared, or if I just see a squared minus x squared, then that's a sine substitution. It just tells us that x is equal to a sine theta. So that's the first thing that we need to know. So in this case, if we look, we got 9 there for our a, so that must mean, or 9 there for our a squared, so that must mean that a is 3. So x is going to be equal to 3 sine theta in this case. We'll take the derivative of that. That's 3 cosine theta d theta, or you multiply by the theta part, and then you just plug it in basically. So we got our square root. So this will be the square root of 9 minus, and I'm going to stick in 3 sine theta. Don't forget that's being squared. We'll multiply that by the derivative, which was 3 cosine theta d theta. So we'll deal with the square root first. So we got the square root of 9 minus 3 sine theta squared. So that's just the square root of 9 minus 9 sine squared theta, which is essentially going to be 3 times the square root of 1 minus sine squared theta. Remember that cosine squared theta plus sine squared of theta is equal to 1, or sine squared of theta plus cosine squared of theta is equal to 1. So if we solve that equation for cosine squared, we'll get 1 minus sine squared theta. So that means that this 1 minus sine squared theta, that's 3 times the square root of cosine squared theta, and the square root of cosine squared theta is cosine theta. So this just becomes 3 times cosine theta. So now, if we look at what we got, when we took the square root of 9, we got 3. So we'll essentially have 3 times 3, which is 9. That's a constant that can come outside. And then cosine theta times cosine theta is cosine squared theta. So this becomes cosine squared theta. And that's all integrated with respect to theta. So now we'll use a half angle identity to rewrite that. So remember that cosine squared theta. Okay. Remember, we can write that as just 1/2 1 plus cosine of 2 theta using that half angle identity. So we can take the 9, I'll keep the 9 out there, but we can also pull out 1/2 because that's a constant as well. And then we just need to integrate 1 plus cosine of 2 theta with respect to theta. Okay. All right, so obviously, if we multiply the constants, we'll get 9 over 2. And if we integrate 1 with respect to theta, we get theta. If we integrate cosine of 2 theta with respect to theta, this will give us 1/2 sine of 2 theta. Okay, and that's what you technically plus c. So that's what you get there. And we'll go ahead and distribute in that 9 over 2, that constant. But we can also change that sine of 2 theta, because remember that sine of 2 theta, that's just 2 sine theta times cosine theta. So we'll change that as well. So in that case, it just becomes 9 over 2 theta plus 9 over 4 2 sine theta cosine theta plus c. So if you've gotten that far, you're on the right track. All right, so let's continue. Let me get another sheet here. So the next step is, and by the way, like I said at the beginning, I'll put it right there. That way I ain't gotta look for it. But like I said before, I got plenty of videos on trig substitution, so this probably isn't the best video if you're just learning the technique for the first time, or if you're just trying to see an example for the first time. Okay, so we just go back to our substitution here. So remember that x was equal to 3 sine theta. So basically, if x is equal to 3 sine theta, then that means that sine theta is equal to x over 3. And we know that the ratio sine theta, that's going to be opposite over hypotenuse. And so that means that the opposite side would be x and the hypotenuse would be 3. So that means that we're missing the adjacent side. So that's where, which we need to find, because we know that we need cosine theta. Remember, cosine theta, if we talk about the ratio for that, that's just adjacent over hypotenuse. And we know that we need the adjacent side because we need to satisfy the cosine theta here. So to do that, you use Pythagorean theorem. So remember, that's just a squared plus b squared equals c squared. And you fill in what you already know. So we got the opposite side, so that's x squared. We're missing the adjacent side, so we'll just leave b squared. And we have the hypotenuse, and 3 squared is 9, so we'll get that. We can subtract x squared from both sides, and if we do that, we get b squared is equal to 9 minus x squared. I'll take the square root of both sides to get b, so that means that b is equal to the square root of 9 minus x squared. So that would be our adjacent side. You don't have to draw a triangle to do this, but sometimes drawing a triangle is helpful. And so it doesn't hurt to sketch something from every now and then. You could probably do it in your head, but some people like to sketch stuff just to make things a little bit more visual. All right, so we got the side for everything now. So this is what the triangle will look like. And now we got everything we need. Okay, so if we go back, sine theta, that's x over 3. We know we needed cosine theta. So cosine theta, that was adjacent over hypotenuse. So that's the square root of 9 minus x squared all over 3. Okay, and we also know that if sine theta is equal to x over 3, then that means that theta, that's arc sine, or sine to the negative first of x over 3. So really all we have to do is just change everything up, and we can actually write our final answer. We kill 2 birds with 1 stone. Well, actually, no, I changed my mind. We're going to do a little bit more work up here because I don't want to skip anything that you guys may not have seen. Okay, so this is what happened. So remember, we had the 9 over 2. Remember, theta is arc sine of x over 3. I was going to skip it, but no, I changed my mind. I'm going to go through it. And remember, we solved for theta, so that's where the arc sine came from. Now remember, this is just 9 over 2 times x over 3 times the square root of 9 minus x squared all over 3, And we know that because we just used these ratios here that we got when we did the Pythagorean identity. We used our, used the Pythagorean theorem to find the adjacent side that we were missing. And we just basically simplify that side over there and, pretty much take it from there. We can go ahead and write our final answer. So we got the integral 9 minus x squared. That's all integrated with respect to x. So the answer to this integral is 9 over 2 arc sine of x over 3. And it looks like we'll get plus x times the square root of 9 minus x squared. Looks like we're going to get over 2, and then we'll add an integration constant. And that would be the solution. So that's integration practice number 10. All right, so yeah, plenty of trig substitution examples. So just reach out to me if you still having difficulty with the process. And obviously I'll continue to post more. You can never get enough integration problems, in my opinion. So that's integration practice number 10. All right, let me know if you got any questions. I'll see y'all next time.